Hey 12s, next video here, it's going to be a long one. In fact, I'm going to split it into two. We want to talk about some properties of definite integrals. Okay, you'll need to remember these things because they may make some complicated examples later on easy to solve, right? They can be some shortcuts to a fast solution. So the first thing I want to say is that even though we're talking about areas, a definite integral can have a negative value, right? Anything that is below the x-axis, right, anywhere where that function falls below the x-axis has a negative value. So let's look at this worked exercise here. I'm just going to sort of work through the last part and we'll jump through and find the other parts. So we're going to sketch this function. Right, x minus 4 from 0 to 6. Let's say it looks a bit like this. So there's negative 4, x and y. That's our x minus 4. It's going to be 4 there. From 0 to 6. So, if that's 4, well, I guess 6 is somewhere like this. And my region is this fairly large triangle underneath the axis and smaller triangle up here. Right there, 6. So, we are going to integrate this function here from 0 to 6. Right. So I'm going to have a negative part and a positive part. So the integral from 0 to 6 of x minus 4 dx equals half x squared minus 4x from 0 to 6 equals, well, I reckon that equals negative 6, right? So that's 36, 18 minus 24 is negative 6. So we've got a negative area. Why did that work out? Well, I reckon this here, 4 by 4 is 16, half of that is 8. I reckon this part here has an area of negative 8. And this part here has an area of 2 by 2. Half times base times height is 2, positive 2, negative 8, positive 2. Combined, those two signed areas have a total area of negative 6. So we can have negatives there. Right. Next thing I want to talk about is the dissection of an interval. That I can chop it up into different parts, combine those things together. Really important property. Right? And we kind of just did that there. Right? Not that it's proof, but it's a good example. I can look at the definite integral from 0 to 4 and the definite integral from 4 to 6. Combine those things together, it's the same as the integral all the way from 0 to 6. Right? I can put something in the middle. I can chop it into two parts, work them out individually, and combine them together. Right? That's dissection. Odd and even functions, you've learned about these before. Yeah, do you remember what odd and even functions are? If not, go back, check it out. But they can be a real shortcut. If we can recognise that we are integrating an odd function over sort of like a symmetrical interval from negative a to a, or in this case negative 2 to 2, we can just straight away write it off as 0 because those two areas are going to cancel each other out. I'm just going to say this equals 0 because it's an odd function. Right? Probably, I want to say that. Maybe I need to prove it, I don't know. It's an odd function. Those two areas are going to cancel each other out. Don't need to go any more work than that, as long as I can recognise that that's an odd function. Now, x squared plus 1, it's blah blah. With an axis at the y-axis, that's going to be an even function. So in this case, I could work out half of it, and I am going to work out half of that integral and double it. Why is that useful? Well, substituting 0 in is often nicer than substituting in particularly a negative number. So I was going to say this is twice the integral from 0 to 2 of x squared plus 1 dx because it is an even function. Therefore, this is equal to 2 times a third of x cubed plus x from 0 to 2, and I'm not going to have to substitute the 0 into this thing. So that's a third of 8 plus another 3/3 11 over 3 times 2, is that equal to... no, hang on. 8 over 3 plus 6 over 3 is going to be 14 over 3 is 28 over 3 by the time I double it. 28 over 3. Okay, or 1 1/9 if you like. There we go. Odd and even functions can make life a little bit easier. Oh, there's a little bit of mess I left behind. Moving along. Intervals of 0 width, and we're going to stop after this. Intervals of 0 width. Well, we're talking about area. If it's 0 units wide, it's going to have no area. Long and short of it. So if you can prove the two bounds are equal to each other, not opposite in sign, but equal to each other, right, A and A, then straight away the integral is 0. Righto, that's the first video. I'm going to chop it up so you can watch the second one with a bit of a rest in between.